So statistics is about collecting, describing, analyzing, and interpreting data. Now there's two branches of statistics. Descriptive statistics, which emphasize the collection and the presentation of data. So you're describing the data, and in most cases, the sample data. A key word here is summarize. So descriptive statistics will summarize the data. Descriptive statistics might answer questions like, what is the center of the data? So what's the middle? What does a typical data value look like? What is the spread of the data? How much variation is there in your data set? How is the data distributed? So we want to know, what does the distribution of the data look like? Is it symmetric, or is it all piled up in one place on one end? Is it lopsided? Is there a pattern in the data when you look at the graph? So we'll look at all different kinds of graphical displays for data, and we'll answer some of these questions. Now, the other branch of statistics is inferential statistics. Here we are interpreting descriptive data, and we're making decisions or drawing conclusions. And these are going to be conclusions about the population from the sample data. So inferential statistics is about generalizing from the sample to the population. Let's look at an example. So we've got a study here that was conducted to examine math and science AT subscores of high school seniors in the U.S. We want to know which of the statements are descriptive and which are inferential. So the first statement, the mean math ACT of a random sample of 500 students was 24.5. So we calculated this mean or average of this random sample of 500 students. We didn't draw any conclusions with it. We didn't generalize. We just calculated. So that's a summary. So this is descriptive. Students who scored above 28 on their science ACT subscore were more likely to major in STEM areas. So we actually drew a conclusion from our data here. So the students that scored above 28, we looked at what happened to those students, and we saw that they were more likely to major in STEM areas. So that's a generalize. So that one is inferential. Now there's not really a mention of the sample and the population here, but that's okay. There's some generalization that's going on, so it has to be inferential. Last statement, bar graph of math science subscores is created here. So we're looking at a bar graph. That's a graphical display. We've created it so we can look at the data. I don't see anything that indicates we're drawing conclusions from that. So to me, that's a descriptive statement.